11.1 exponential functions. It's MA 912, AR 5.4, 5.6, and 5.7. MA 912, F.1.2, and 1.6. We're going to evaluate and graph exponential functions, evaluate the nature base E and graph natural exponential functions, and use exponential functions to solve application problems. So, polynomial irrational functions. Remember, previously, f of x equal to x squared and f of x equal to x to the negative 3. The constant exponents are positive or negative exponents, and the variables are the bases. The difference between the polynomials and the exponentials is that the numbers, the constants, are bases, and the exponents are variables. In this situation, they flip the position. So in example 2, it says, evaluate each function, use a calculator only if it is necessary or more efficient. So when we look at this problem, it says f of x equal to 2 to the x. So they want us to do, when it's f of 3, so they want us to do 2 to the third. F of negative 4, so it's 2 to the negative 4th. And f of pi, so 2 to the pi format. So the first one, we don't need a calculator, it's 2 to the third. It's basically 2 times 2 times 2, which gives us 8. The second one, we're not allowed to have negative exponents, so we first make it 1 over 2 to the 4th. And then we see 2 to the 4th is the same thing as 16, so we get 1 over 16. The last one, 2 pi, you need a calculator for that instance. You're going to set 2 and raise it to the pi format. So I would put 3.14, and we get 8.81 or 8.2. You can leave it as 2 to the pi, but if they want an actual numerical value, then you have to use a calculator. On B, it says g of x equals 12 to the x. So we're going to say the same things. G of 3 is 12 to the third power. And we have g of negative 0.1, which is 12 to the negative 0.1. And then g 5/7. So you have 12 raised to the 5/7 power. So the first one, it's 12 times 12 times 12. So we're going to do 12 to the third. We get 1728. The second one has a decimal portion, so you're going to do 12, hit the exponential key, and then you want to put the negative sign, because it's 0.1, close the parentheses and hit enter. So we get a decimal answer of 0.7799. And then we have the 12 to the 5/7 power. So 12, hit the exponential key, 5 divided by 7, close a parentheses because you wanted to include it. And we get 5.899 in that situation. On C, it says h of x equals 1.04 raised to the 2x power. So they want us to do it when h is 0. So we see 1.04, 2 to the 0 power. This one's going to be individual, so we have 1.04 raised to the 0 power, and we know anything raised to the 0 power is 1. Then we have h of negative 2. So we have 1.04 raised to the 2 times negative 2. 1.04 to the negative 4 power. Now apply the calculator, 1.04, exponent key, negative 4 power actually. Uh, 1.04 exponent, negative 4. So we get 0.8548. And then we have h of radical 2. So it's 1.04, 2 times the square root of 2. So we have 1.04 exponent and do 2 radical 2. Close the parentheses before you hit the inner sign, and we get 1.173. Example 3 wants us to do graphing of exponential functions. So in the same coordinate plane, they want us to sketch the graph of each function and determine the domain and range of each function. So I did table values, from -2 to +3, and they gave us the function f of x equals 2 to the x. So they want us to do 2 to the -2, which is the same thing as 1 over 2 squared, or 1/4. Then 2 to the -1, which is 1 over 2, or 1/2. 2 to the 0 power, that's a 1 value. 2 to the first power, that's 2. 2 to the second power is a 4. 2 to the third power is an 8. So we have our order points. When x is -2, y is 1/4. So we're a fourth of the way up. So somewhere around there. When x is -1, we're at the halfway mark. When x is 0, we're at the 1. When x is 1, we're at 2. When x is 2, we're at 4. When x is 3, we're at 8. So we're seeing this is our f of x equation. Now they want us to graph our g equation in the same graph. So we need to find our g values. So they said when it's 4 to the x power, so we have 4 to the -2, which is 1 over 4 squared, or 1/16. 4 to the -1 is 1 over 4. 4 to the 0 is a 1. 4 to the first is a 4. 4 to the second is a 16. 4 to the third is 64. Obviously, this one, 364, we're not going to be able to plot it. It's going to be off the graph, so we're going to plot the other ones. So when x is -2, the y is 1/16, so it's closer to the y line. X line, x is right here. When it's -1, or it's a fourth of the way. When it's crossing the same ordered point. When it's 1, we're at the 4 mark. When it's 2, we're at the 16th mark. So this graph is doing this way. This is our g of x. So I want us to identify determine the domain and range. So notice that all the x values are going from negative to positive. So the domain for both is -infinity, +infinity. The range for the f of x is going to hit from 0. Notice that both graphs did not drop below 0. So for both f of x and g of x, it's going to be from 0 to infinity. Example 4, again, they want us to find in the same coordinate plane, sketch the graph of each function. So notice that these two have negative exponents. But the bases are the same, but just negative exponents. So on my tables, I started with -3 to +2. So we're saying 2 to the negative of -3. Remember, that's why I put it in parentheses. So you get actually 2 positive cubed, which is an 8. We get 2 to the negative of -2, which is 2 to the +2, which is a 4. 2 to the negative of -1 is 2 to the first, which is a 2. 2 to the negative of 0, that is still 2 to the 0 power, that is a 1. 2 to the negative of 1 now is 1 over 2. 2 to the negative of 2 is now 1 over 2 squared, which is 1/4. So notice that we are starting positive and decreasing. We're starting from the y-axis at the top and going in downward direction. So when x is -3, we're at +8. Then it's -2, we're at 4. When it's 1, we're at 2. When it's 0, we're at the 1 mark. When it's 1, we're at the halfway mark. And then at 2, at the 1/4 mark. So we are approaching the x-axis. We do the y-axis one, the g of x equation. So we have 4 to the negative of -3. That gives us 4 to the third, that's +64. 4 to the negative of -2, that is 4 squared, which is 16. 4 to the negative of -1, that's 4 to the first, which is 4. 4 to the negative of 0, that is still 4 to the 0, which is a 1. 4 to the negative of 1, that is 1/4. 4 to the negative of 2, that's 1/4 squared, which is 1/16. So now we're going in the other direction. So obviously the 64 would be too high to plot. So we're going to start with the -2x at 16. Then when it's -1, we're at 4. When it's 0, we're at the 1 mark again. And then we're going to hit 1/4 and then 1/16. So it's coming down, approaching the x-axis. So again, in this one, our domain for f of x and g of x is -infinity, +infinity. The range, though, does the opposite of the previous problem. The range of the f of x and g of x, notice that the y values did not drop again below 0. So again, we're from 0 to infinity.